The Voyager spacecraft have been traveling through the cosmos for decades, traveling 1 million miles a day, every day. Communication is received on Earth from the Voyagers through some gigantic antennas at NASA's Deep Space Network. The giant antennas are located roughly equidistant from each other in Madrid, Spain, Goldstone, California, and Canberra, Australia. The antennas were built to communicate with not only the Voyagers, but other spacecraft and all the robotic rovers, orbiters, probes studying the Sun's corona, the Kuiper Belt, and continuing exploration of Mars, the Moon, and other worlds in the months and years to come. Since Voyager 2 left the solar system moving downward relative to the Earth's orbital plane, only Canberra's antennas, located in the southern hemisphere, have been able to send signals to Voyager 2. All three locations are able, however, with periodic updates, to receive signals from Voyager. Voyager's 20-watt signal is 20 billion times weaker than a digital watch battery by the time it reaches Earth. And the farther away Voyager gets, the harder it is to receive these incredibly weak signals. That problem is compounded by the fact that, in spite of several updates, the DSN antennas were 50 years old and long overdue for an overhaul. It was determined that the subnet of 26-meter antennas at the Deep Space Network stations would need to be upgraded to 34-meter antennas with added X-band capability. The decision was made to suspend communication with Voyager so that the necessary upgrades could be made. Since Canberra is the only antenna capable of sending signals to Voyager, the Earth would be out of communication with the spacecraft for more than 8 months. Voyager 2 was able to call home on Canberra's smaller dishes during the shutdown, but none of the smaller antennas could send signals to the spacecraft. If something went wrong, NASA would be powerless to send signals to fix it. NASA started with a refresh of the dish's electrical cabling, power supply, and cooling systems. The maintenance effort also saw the installation of a new X-band frequency cone that improved the facility's sensitivity. Doing so required a crane capable of hoisting a 3-ton cone to a height of 20 stories. NASA was concerned about having no communication for an extended period of time, however, because Voyager has a device on board called the Command Loss Timer, something like a dead man's switch, which is used to help the spacecraft determine whether it has lost contact with the Earth and should protect itself by going into a form of electronic slumber. All 5 of the spacecraft's still working science instruments were turned off by the fault protection routine, allowing the spacecraft to automatically take actions to protect itself. After the 8-month period of time that no communication from Earth was received by Voyager, NASA attempted to recontact the spacecraft. A test signal was sent to reset the timer, and it successfully told Voyager to continue operating. Voyager 2, however, did not execute a scheduled maneuver in which the spacecraft rotates 360 degrees in order to calibrate its onboard magnetic field instrument. Telemetry analysis indicated that an unexpected delay in the onboard execution of the maneuver commands inadvertently left 2 systems that consume relatively high levels of power operating at the same time. This caused the spacecraft to overdraw its available power supply. Engineers turned off one of the high-powered systems and turned the science instruments back on. Engineers continued to review the status of the rest of the spacecraft to return it to normal operations. Mission operators were able to confirm that the science instruments were returning to normal science data and continued to evaluate their health. Voyager has continued to be stable, however, after the 8-month silence from Earth. The upgrades were completed in time for the February arrival of the Perseverance rover on Mars.